Hey, what's going on, guys? Let's do this problem right here. The question is asking how much heat is released by burning 27.5 grams of CH4. So we have this equation that is provided right here, and this information says that for 1 mole of CH4 this much heat is released. This negative sign represents released, so we know that this is released number, right? And then let's see. So if 1 mole is making this much amount of joule, then we have to calculate 27.5 gram how many moles we are going to have. So to find that one, we have to divide this one by molar mass of CH4, right? We have 27.5 gram. That doesn't tell anything, right? So since we have the mass, that is 27.5 gram, and we know that if you divide 27.5 gram by its molar mass, gram per mole, that's going to give us the mole. So let's see where we get. So first I put this one right here, 27.5 gram CH4 times molar mass of CH4. So in 1 mole of CH4 there is 16 gram, because 12 is carbon's molar mass and each hydrogen has 1 gram of molar mass. So this is going to be 16 gram, right? 16 gram of CH4. So from this one, if you calculate this one, that's going to give you 1.72 moles CH4. And we already know that 1 mole of CH4 makes this much amount of energy. So 1 mole CH4 makes negative 890.4 kilojoule of heat, right? So this is the information we have. Now the question is how are we going to convert this one into calculate this much amount of this much amount of mass. So we know that this is equal to negative 890.4 kilojoules per mole, right? So let's write this one, negative 890.4 kilojoule per 1 mole of CH4. 1 mole of CH4. So here we have 1.72 mole of CH4. So there is a conversion factor we can use. We know that two kind of conversion factors are there. Like you can put 1.7 moles of CH4 over 1, or 1 over 1.7 moles of CH4. So these two are kind of conversion factors. So here we want the moles to cancel, right? So we want the mole in top. So if we multiply by this one by this value, that's going to give us the kilojoule. So let's do this one. So this is going to be multiplied by 1.72 moles of CH4. So that's going to give us 1530 kilojoule. So here's a tricky part, right? Whenever we state that it's released, so if we say it's released, we don't have to state the negative sign. If you don't say it's released, we have to put delta H is equal to negative 1530. Released basically represent negative. So that's the main thing, and that's how you do this kind of problems. I hope you guys find this video helpful. See you next time.